Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine this, you ask an AI coding agent to implement a new feature in your production system. It passes all the tests, everything works. You deploy it, and weeks later, your system is breached. This is the story explored in the paper. Is vibe coding safe? Benchmarking vulnerability of agent generated code in real world tasks by Songwen Zhao and Dangqing Wang. And what they discovered is honestly unsettling. Vibe coding is the new paradigm. Instead of writing code line by line, engineers describe features in natural language and AI agents implement them. Tools like coding agents inspect repositories, edit multiple files, run tests, and refine patches autonomously. It feels magical. But here's the problem, most benchmarks test small functions, single files, single turns. Real software doesn't work like that. Real repositories have hundreds of thousands of lines, multi file edits, complex dependency graphs, and the subtle security landmines. So the researchers asked, what happens when coding agents operate in the real world? To answer that question, they built SysVibes, a benchmark of 200 real world feature requests derived from actual vulnerability fixing commits across 108 open source repositories. Each task starts from a real historical security bug, masks the secure implementation, asks the agent to re implement the feature, then evaluates using functional tests, security tests. On average, 162,000 lines of context, 170 lines modified per task, 77 different CW vulnerability types. This is not toy evaluation. The pipeline is fascinating. Step 1, mine real vulnerability fix commits. Step 2, extract the security tests and functional tests. Step 3, mask out the secure implementation using an LLM. Step 4, generate a GitHub style issue describing the missing feature. Step 5, verify that the description justifies the secure implementation. Even the execution environments are automatically dockerized by agents. Then they validate. Vulnerable version fails security tests. Fixed version passes both. Masked version fails everything. Only then does it become a benchmark task. They evaluated SWI agent, Open Hands, Claude Code, using frontier models, Claude 4 Sonnet, Gemini 2.5 Pro, Kimi K2. Now here's the shocking part. The best system, SWI agent with Claude 4, achieved 61% functional correctness. Sounds great. But only 10.5% were secured. That means over 80% of correct solutions contain vulnerabilities. It gets worse. Even when they improved reasoning models like Gemini 3 Pro, functionality skyrocketed. Security barely improved. Security and correctness are diverging objectives. And different models avoid different CWE categories. 58% of vulnerability types were not overlapping between models. One qualitative example in Django, the task required implementing verify password. The agent wrote a function that passed functionality tests, but it returned early for invalid users. That introduced a timing side channel attack. An attacker could now enumerate valid usernames, functionally correct, security disaster. They tried mitigation strategies, generic security reminders, letting the agent identify CWEs first. Even giving the Oracle vulnerability type result, security improved slightly, but functional correctness dropped. Agents over-focused on security and broke functionality. The conclusion is clear, vibe coding works, but it is not safe by default. Security is not an emergent property of reasoning, it must be explicitly optimized. And until coding agents treat security as a first class objective, deploying them blindly in production is a risk we cannot ignore. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.